Hello, welcome back to Turin Chemistry, and today we are about to explore the concept of nucleophiles versus electrophiles. Nucleophiles and electrophiles. To start with, it is one of the most important and the fundamental concept in organic chemistry. Organic chemistry is one of the most dreaded concepts for many students. So, when we start to understand the most basic and fundamental concepts like nucleophile and electrophile, it gives us a very important basement or the fundamental to understand how the reaction mechanism takes place. In all kinds of examinations of A levels, CBSC, NEET examinations, and every other competitive examination which involves organic reaction mechanism, it all boils down to the basic concept of nucleophile and electrophile. When we are able to understand the electron movement, it becomes pretty much easy to understand the steps involved in the reaction mechanism of any kinds of reaction. There are lots of naming reactions which has a very high weightage in all kinds of examinations. So when we understand this very fundamental of the direction of the electron movement, then it will be easy for the students to solve the organic reaction mechanisms. So we start with this. So when we see about a reaction mechanism, this is the very heart of organic chemistry. When we are able to understand the reaction mechanism, so that just gives us a great understanding about the overall organic chemistry. So what is a reaction mechanism? It is about the step by step approach of how a reaction takes place. What kind of the intermediates are formed, what kinds of the electron tracking is taking place. These can be understood through the step-by-step reactions. For understanding a reaction mechanism, we start with the most fundamental concept of nucleophile, nucleophile, and electrophile. In any reaction mechanism, it is important to find out which is the electrophile, which is the nucleophile in that reaction in order to proceed further and to understand how the bond breaking and the bond formation takes place. So, as the name suggests, this is nucleophile. So, it loves the positive charge. It is nucleus loving, and this electrophile is electron loving. So this nucleophile is electron rich. We all know the opposites attract. When some entity is electron rich, it gets attracted to the positive charge of the nucleus or the positive charge carrying entity. It is electron rich. So it has a large cloud of electrons. So it is very electron rich. And in case of this electrophile, so it just loves electron, meaning that it is poor in the electron capacity. So this is electron poor. So this is the first point. It is nucleus loving, it is electron loving, and this is electron rich, and this is electron poor. So it has a lot of electron, so it attacks the electrophile. So this has the ability, when there is a lot more electrons, the reaction takes place in such a way that the electrons move from the nucleophile to the electrophile. So the nucleophile attacks and the electrophile gets attacked. So this will be the recipient of the attack, and this in the nucleophile is where the reaction initiates or the electron flow initiates. So this electrophile gets attacked. So this will give us the characteristics of nucleophile and electrophile. So, first, before we proceed to understand any reaction mechanism, we have to identify which is the nucleophile and which is the electrophile. So, we have understood from now. So, the organic chemistry is all about electron movement. We have to track how the electron moves and what kind of the intermediates and species gets formed in the reaction mechanism, which leads to the final product. So we have now understood the electron movement always takes place from nucleophile towards the electrophile. So now we have to learn how to identify the nucleophile and electrophile. So this has a negative charge because this is electron rich, and this has a positive charge because this is electron poor. And so the first way to identify it is the nucleophile, the nucleophile has a negative charge, and the electrophile has a positive charge. So the second possibility to identify is the nucleophile sometimes or has a lone pair of electrons in them, and the electrophile sometimes has a carbon with a partial positive charge, which has a partial positive charge. So these are the way to identify the nucleophile and electrophile. And the final way is the nucleophile has double bonds. So they could be alkenes. So they could be alkenes. So they are doubly bonded compounds. And in case of electrophile, the electrophile sometimes are found to be bonded to the more electronegative atom. More electronegative atom. So this sums up that there are three kinds of ways to identify which is the nucleophile and which is the electrophile in all kinds of reaction mechanisms. So the nucleophile will possess a negative charge, and the electrophile will have a positive charge. Nucleophile might have a lone pair of electrons residing upon them, while the electrophile sometimes have a carbon with a partial positive charge acting as an electrophile in that reaction mechanism. So the third possibility is these could be compounds with double bonds. So they could be alkenes. And here we could see the compound might have a part of it attached to, a bonded to a more electronegative atom. For example, in the periodic table, the electronegativity trend increases from left to right. So towards the P block, the electronegativity is increasing. So this is just an added tip. So let's move on to the an example. See, here we have H, Br minus, H plus, Br minus, and CH2, double bond CH2. Can you identify which is the electrophile and which is the nucleophile here? So we understood from the characteristics that the nucleophile will have a negative charge. So this is a nucleophile. So nucleophile might also have a double bond in them. So this is also a nucleophile. This has a positive charge, and this could be a part of HBr. So this is a electrophile. So it has a positive charge. For example, this is a positive charge. We see a simple example of alkene bromination. This is a very simple example of identifying the basics and fundamentals of nucleophile and electrophile. So we have a simple alkene. Ene is the substituent name for double bonded compounds. So this is ethene. We know this has two carbons, so we have a prefix eth, and it is a double bonded compound, so we have ethene, ene as the suffix. When it undergoes bromination, dibromination, so now we know that which is the nucleophile here. So this is the nucleophile, okay? So this is the nucleophile because this has a double bond. So this is the electrophile. So what happens? The electron movement always takes place from nucleophile towards the electrophile. So the reaction has to take place from the nucleophile to the electrophile because the nucleophile has the ability to attack and the electrophile will have the ability to get attacked. So this nucleophile comes and attacks the Br2, Br bond. It breaks the Br bond leading to Br plus and Br minus. So then there is a formation of a bromonium ion. So we have it forms a bromonium ion which again has a second attack coming, and this is the in case this is the nucleophile here, and this part is the electrophile leading to the formation of CH2 and here is the bond cleavage which leads to CH2Br and CH2Br. So this is 1, 2 dibromoethane. This is it's the two-step bromination. In the first step, we see there is a formation of a bromonium ion, and then we see that the second bromo will also be formed. So in this case, we get vicinal dibromides. Vicinal dibromides. So vicinal mean the halogens or the groups or the substituents getting attached to the two different carbons and not on the same carbons. So this is a vicinal dibromide. So thank you very much for watching this video. If you have some questions, please drop your comments below in the comment section and I will be able to address your questions and comments. Thank you very much for your time.